Okay, good afternoon. So I hope you enjoyed lunch and demos and actually when having a discussion with my colleagues, Risto he developed a measure and he said that there is no line in food and food is not bad. So the demos must be interesting. I hope you agree, but there was no long line for the food, and quite many people were looking at demos, or you were just too timid to go to the food because I was warning about lines. But yeah, this measure, according to this measure, then the demos were good. But yeah, we'll hear your feedback later. Let's go to the agenda. So Juuso Autiosalo will continue, and his topic is deeper dive to digital twin concept, and also I expect to hear something about future of digital twins.
Yes, thank you, Kari. Well, about the headline, deeper dive to digital twin concept. Well, actually, this is quite exactly the opposite of a deep dive. So I'm looking at, I have done the deep dive so that you don't have to. And I will kind of present the findings from a high perspective and looking to the future of digital twins. And these features are kind of main message. So, what is a digital twin? Could it be a combination of different features? Basically, this is the contents of this presentation, so I will shortly go through each of these. I will not go through every detail on the slides, but I will kind of lift something up from each slide, and then I will kind of focus on the data link, which is some kind of data collecting tool, kind of the heart of the digital twin. And that's kind of the main message. So simulation model is in kind of, for engineers, it is often the digital twin, how they see it. It's used to analyze the behavior of the physical twin, and well, there's use cases, there's some examples, digital twin shop floor. It has been developed by this Fei Tao professor in China, and then virtual prototyping is common example, and all that kind of stuff. But how do we see digital twin through the user interface, or what does the digital twin look like? Well, it looks a little bit different for every user, I hope. In the engineering context, we have maintenance, design, sales, operator, manufacturing, towards kind of the engineering side of this Ilmatar crane, and maybe we provide something to the outsiders that are kind of not in the, from example, in the Konecranes engineering ecosystem. Then data has to be somewhere. Where is it? Well, it's in some kind of database. It doesn't have to be so that the database is kind of one single place. You can do kind of also analysis in the database, but this is kind of a feature for the digital twin, and sometimes just showing the data may provide enough value for the digital twin. So, but usually you have to analyze it a bit more. Then identifier. How do you access the digital twin on the physical world or digitally? In the physical world, you could use a QR code, scan it and go into a website that kind of shows something about them. Of course, there will be only the publicly available material, but maybe there could be links to material that is not public, and the links you will have to kind of use the user authentication after for accessing that link. But user manuals, that kind of stuff, we can provide it to everyone. Then artificial intelligence. We haven't yet implemented this, but kind of fun idea is kind of to compare the potential of a regular car to an autonomous car. So the regular car doesn't have artificial intelligence and you have to all the time drive it, but an autonomous car has artificial intelligence and the potential is hugely different. You don't need all the time some guy behind the wheel. And similarly, digital twin with artificial intelligence, it has hugely more potential than a digital twin without artificial intelligence. Then when we are developing something, we often forget this security aspect, but we should kind of all the time keep it in mind. The digital twin has to be secure so that we can use it. I think I like to compare it to why do you want lock and keys in your apartment? So that you can leave it kind of there and leave the apartment for the day to go to work. And similarly, we need security for the digital twin. Computation, of course, each part of the digital twins has some computation, and it can happen in the device, in a gateway device, in the middle of locally and cloud, and it can be on the cloud. But for example, we could use some kind of computation service to kind of do the analysis, the heavy analysis. So that's why I want to bring computation as a feature. And there's more features that has come up. For example, I think processing data or analysis libraries, they could be there. Don't quite go to any of these categories. It's a little bit under the artificial intelligence feature, but it's kind of the analysis, they are more kind of mechanical, and people can write kind of analysis so that for the specific case, and just data processing that has been implemented quite manually. Then how to combine these blocks or features. Some people call them building blocks of digital twins. So you can also find some academic papers on that term. I'm suggesting some kind of data link. between these features. It can be some kind of data collecting tool. It can be kind of an abstract link between these features, and that's what it's right now, and also in our project demos. It's an abstract link between all the features. But maybe in the future, could it be even kind of real link, some kind of digital twin broker with APIs that could be used to kind of to machine-to-machine communications and provide the data that is related to one digital twin and one real-world entity. Then some thoughts about enterprise context. Right now, currently, it's done on the red lines. Each kind of system is linked to another, and there's kind of we build them as we need them. But instead of that, could we always build the communication a little bit better so that it would go through the digital twin data link, so that all of those, we don't have to. It's a little bit mess, the red lines, and it's more simpler, the black lines, and it gives kind of more potential for the data because it's more easily available. And as you may have kind of heard about my speech, this is probably the most difficult issue between the data kind of digital twin data link. Many standards for IoT has been proposed before. OPC UA was one of them, and each of them are kind of trying to achieve the same thing, that we are almost the same thing. They're kind of wanting to be the one platform to provide all the data. But what we are trying to do with this our data link or digital twin broker, we are kind of trying to build on top of any other system. So we use everything that is available and try to kind of combine them, because and that's also where kind of the ecosystem comes. The digital twin broker, we try to do it very simple, so it has nothing use case specific. It's kind of abstract, but it enables as much data transfer as possible. Why is Excel a popular engineering tool? Because I think it's because it's so flexible. You can do with it anything that you want, calculations, and that's kind of the aim that I want to achieve with the digital twin. Yeah, this product, we have many terms for the digital twin. Product avatar is one of them, and I'd like to lift this, that this is not exactly a new concept. It has been proposed in 2006 by Karl Rybernik in this paper. Also some of our researchers, Kari Fremling, for example, was dealing with similar kind of ideas in the logistics context. But this is so difficult that even though it's an old idea and kind of a dream, but it's not reality yet. There is some examples in some kind of cases. I think they made it quite well in the logistics context, but go a little bit higher, make it kind of more available for everyone. So, conclusion. Is it a conclusion? Probably not, because there's a lot of open questions in the air, but maybe you have some ideas of what I have tried to say here. Maybe all of these features, they could be kind of in a catalog for that you could select each feature for your own digital twin. So it's kind of digital twin offering. So you want to buy a digital twin, then you select some features from there. So idea. Maybe in the future. Let's hope so. Because as Valtteri mentioned, you always have to find your own business case. And we did that for the Ilmatar crane and for engineering design and product development, and that's one aspect. But could we do some more? Could we have the digital twin of humans or buildings? I don't know. Well, I say yes. Next presentation will be by Miika, Valtonen, and will show the creation of Framery smart booth, and that's another example. So we have a lot of possibilities. So, any questions? Yes.
Yes, this about this sort of race towards this developing the standard for this data link that you mentioned, of which an example would be the one that Kari Fremling is proposing, and you mentioned some others. So I imagine that you have done quite a lot of research in those. Does it seem like is the race about to be completed at some point, or is it still like a mess where everybody's sort of proposing their own idea?
Yeah, the question was about kind of will there be a standardized data link anytime soon, something like that. So, and currently, my answer is that currently it is a mess. It's kind of distributed everywhere. We have a specialist on this case, Tuomas Tiainen, and he's kind of trying to find answers to that question. Yeah, to be seen. And there.
Just out of interest, you mentioned also making digital twins out of 3Ds. How would you see the challenge of simulating the human brain?
Okay, about digital twins of humans and simulating the human brain. Yeah, difficult question and good question. Maybe artificial intelligence is kind of trying to do that with the deep neural networks and their nodes. Perhaps that could be part of digital twins also. And we have openings in the kind of combining uh, artificial intelligence and machine learning with simulation. So maybe, yes.
Okay, thank you for questions and thank you Juuso again. So let's give applauses to Juuso. And we'll go forward in our agenda. The next one is Miika Valtonen. He's a senior solution architect at Remion, one of the partner companies in our project. And he'll explain how to build a digital twin of smart booth and what values it provides. So, and first of all, I think what is smart booth? You're welcome, Miika.
Thank you. Does this work? Yes. So, good afternoon on my behalf. I'm Miika Valtonen and I come from Remion. And today I would like to talk you about smart booths. So, first of all, which of you know what the Framery booth is? About 1/3? Okay. So I better explain a little bit more about the smart booths. So Framery has created these booths for open plan offices for now a few years. I think it was about 10 years ago when they started developing booths into which you can go and talk freely and you don't disturb the outside. And that's what we're going to look into, and you'll see a couple of pictures of them soon. But let's talk about first why am I presenting this subject here. So we are part of this consortium here because we were operating the IoT business, and we develop software for several companies, do data collection, processing, analysis, and then visualization. And this has been one of the projects we have been working on in the last 1.5 years. And I've been part of that because I work in the R&D team in our company. And so what I would like to present to you is the subject, how we went through the project and what we did, how did we create a digital twin for a phone booth. So we started from the scratch. We had a meeting with Framery and we discussed about the opportunities that we could have with them, with digitalization, and how could we make first their booth better and smarter. And that's their booth. It's very simple, it's elegant, and what they want to promote with that is that it's silent when you're inside, or if you are a very talkative person, you go inside and you may yell in there, and the other people outside won't hear you. So that's one of the things they want to promote and make people then happy and bring happiness to people when they can have good productivity when working inside or outside the booth. Well, what else do they provide? They provide style. They have space-efficient structure for the booth. It only takes 1 square meter in size from the floor plan. And of course they have ventilation, work light, chair desk and electrical outlet in there, so you can work there for longer times. But it still doesn't have any smart features, and it's hard to create a digital twin without any of them. So we proposed that we could put in some smart features into them, and that's how we went along with this project. And the things we did put in here, I'll cover them here in the next steps. So first of all, we applied some sensing technology there so that we could sense the utilization rate. So when the person is inside the booth or using it, and we can calculate the booth times, the different rates, and the availability of the booth can be shown to the users or different personnel that are interested of the booth. Then we enlarge the sensing capabilities to sense the posture of the user. So when he's sitting, standing, or being in a half sitting, standing posture, we can know that. Then we know if one takes a laptop on the table or places on his hands there, so we know about the activities happening on the table. We sense also the door operation. When you touch the handle, open the door, we know the angle and the movement of the door all times. We can sense the people flow outside the booth, so we know when people are just walking next to it. So that can bring probably lots of information to architects, say, for example. Then we have environmental sensors within the booth. We monitor the air quality and the light level, for example, temperature, relative humidity, and carbon dioxide. And we as humans develop quite a lot of carbon dioxide, so they do have fans in there to circulate the air. And for that performance, we measure the fan and the light performance in there, and also how the sensors communicate out from there. Well, going on, we applied a strip there, so we can do gestures. You can give gesture feedback that you're happy or you're not happy with the booth. And there's a question assisting you in which you can answer, does this booth assist you in concentration, for example. And going on, we applied some multifunctional lighting in there, so we can see the reservation status as a green light, that it's now free and available. You can go in there, and we can see the registration of the feedbacks you give to the booth, or use it for mood lighting, for example. And all this data is gathered to a cloud service. That is was one part of our products, and we deliver the data to this cloud service wirelessly and do the data processing in there. So now, having a smart booth, we can go on forward and think about creating the digital twin, because without any IoT data, it's quite little we can bring out information out of this booth and what's happening in there with the humans. So what do we have in a digital twin? We have lots of properties that we can apply there, but as Valtteri has explained today, there are certain properties that are applicable to a certain company or certain people that are willing to investigate into the properties of the booth. So first of all, Framery booths have a QR code, so you can recognize them with an identifier. We can bring in the data to the digital twin from other sources as well, so from which customer the booth comes from. So we have identifying data that we want to include in the digital twin, so we can combine further data or join it with this identifying data. Well, we covered the sensors we have in there. We have lots of raw IoT data that we include in the digital twin data model, and there are lots of measurement signals and different events happening. So for example, events could be arise when people come in or out of the booth, or the temperature is there just too high for people to enjoy the booth experience. Then we can apply some location data into the digital twin. And location data can be, for example, in a map format. So on a floor plan, we know where certain booths are placed. So in this sense, we actually may have lots of digital twins, multiple of them. And here, by combining the location data, we can then think about the relations between the different booths and what information the fleet view can bring from the data. Well, of course, having the raw IoT data, we want to process it, and we want to make out, for example, human productivity out of there. So the booths are for humans, so that they could be effective and they would enjoy their work. So Lots of large companies like Amazon, Twitter are using them from Framery. So they want their employees to have a good place to work. So we want to process the data and get good indices, values out of there. We want to know is the environmental quality within the booth good when there's people in, but also when the people are out of the booth, we can measure their quality outside the booth. So it can be used in two ways. Also, the technical reliability is measurable then through all the sensor data. And finally, we want to include in the digital twin a 3D model so we can visually show what's happening within the booth when someone is using it. And some of you may have used it at our stand in there in the other building, the tablet view, to see how is this operating. So this is the information we want to bring into a digital twin, and we see a digital twin as a thing, as a data model in a technical sense, but from the end user perspective as a tool from which a user can get access to different types of data. So if we want to see what's in the twin, what views can we see in the digital twin, and we have provided 3 different types of views. We have this 3D model and how the user works in the booth. We can show it in real time, how the door is opening and how the lights are lighting. We have historical trends in our regatta portal, where we can see the booth times, the environmental values, and so on. And then we can apply this location data with heat maps, and with that provide more information on their usage. If we look more closer into this, we can see here that there is the man just sitting in the booth, and this can be recognized real time. Then we have some statistical information there next to it, how the booth operates, how is its usages, and what type of feedback we have been getting from it. The 3D view is rotatable, so you can look it from different directions. In this portal view, we have lots of data, raw data and process data that can be seen. There's statistical data about the status of the booth, if it's available or free at the moment. We can see the environmental quality, the last score that has been given by the user of the booth. Then the booth times are there, up there in blue. And then in the middle you can see those lines depicting different sub-indices of the environmental quality of temperature, relative humidity, and then carbon dioxide. And you see those dips or rises in those curves while a person is within the booth, so while there's a triangle up there in the blue. And below there's the last 30 days feedback figure, so what type of feedback has been given in the booth about its operation. In addition to this dashboard, you can see here there's different dashboards. You can get more information out of different signals, and you can get weekly reports, events, the map location where the booth is located, and access other booths. At the moment we have 2 booths implemented, so this is still at the concept stage. It's not a product yet, and it's up to Framery to take this thing forward in the way they want to, and we're providing this to their R&D team to investigate on and go further. Well, then going on to the third type of the view, we have here in the view utilization depicted as a heat map, and there's a blue color showing that there's very little usage in that area of the map. And in the lower left corner you see the blue area where there is 2 booths actually located next to each other, and we can give some suggestions that if you would move one booth from there to a red area, you could see from see that those both areas would change green, because the usage would be distributed more evenly. And now, while in the red areas there's lots of usage and there's not usually free booths, it would help to have another booth there, so that there would be free booths available in that section. And this map is actually a place where those booths were placed once, but but this data here is simulated. It's not true data at this moment. And there's other types of heat maps we can draw from this data. There's session duration, usage type. So if people are standing or sitting, we can see how that distributes spatially. And then customer feedback and environmental quality can be likewise depicted. So how do we make value with this type of a digital twin that incorporates all this data? Well, we have this design and IoT data that we've been looking at, and now we want to take it to some people. Well, now we first created this digital twin that incorporates all these different types of data and brings it together so that we can easily access it and show it through some easily understandable user interface for different people. So who are the people who might want to use this all data through this digital twin? First of all, the end users. So the Framery's customers, let's say Amazon's employees. They might want to see the availability of the booth. If there's space available, is there a green light that they can go in there, or do they look it up from some calendar? We don't know yet how it's going to be happening. They also know what type of feedback is getting from certain booths. Well, going on, then let's say Amazon wants to have a check where should be these booths be placed, and they can check on the productivity of each booth, about their layout. They can optimize it and think about the environmental quality, and probably a facility manager is the guy who does that. Well, in the human relations manager might be thinking about user happiness. So what type of feedback is getting, what they are getting from each booth, and about the diary, where the people are spending their time during the day. The building architect might be interested in the people flow around the booths, so they could optimize the structure of the building. Well, going to Framery, their designers might be interested in different usage types. Do they sit or standing there, or being in a halfway? So what's the best chair, for example, to be placed in the booths for this customer, and what do they need? So this is actually something that could be transferred even to the sales personnel. And of course, about the feedback, they're interested as well. Also, the service personnel can know about the technical reliability through this type of information they can access through this digital twin. And the brand manager may also promote the brand using the feedback scores that they get through this digital twin. And finally, the sales personnel might think that in this geographical area or with this customer, they use this in a specific way, and they want to then optimize their use or sales with that information. So all in all, we have developed a digital twin concept with Framery during the last 1.5 years, and made it a multi-purpose IoT tool that they could use to get information for these different interest groups and different people groups. And likewise, as we have been talking about this subject with cranes and other machines, we can make with these ideas digital twins for stones or breads as well. So we don't know what's going to happen in the future. But this is my talk today, so Thank you for your attention, and I'm then ready for any questions.
Meanwhile, the audience is thinking. Maybe I'll ask one question. So when a person enters to the booth, is there a sticker that he or she will be surveyed in many way, and does the person have to somehow like accept the conditions of being there?
Well, at the moment there's nothing that they could sign, or they could know it from anywhere that they are being surveyed.
Okay, maybe I'll take it. It's anyway inside the employer's premises, and maybe it belongs to the employer's authority to be in under surveillance.
Yes, usually there's an owner to the booth, and probably it would be to have a sign. But the monitoring that's being done for these people is. It's not so that you could recognize who's the person and what he or she is doing, so we don't know the identity of the person.
Okay, now there is a question from audience.
Yes.
How much premium can you charge for these booths when you have this digital twin there that tells all these fancy details of the usage and so forth? How much more money you can get?
Yeah, the question is how much more money can you get with these premium features? Well, I don't have the answer for that. I'm sorry, because I'm not operating for Framery and not doing that section. So it's up to them to decide how they want to value this and what type of a service or product they want to develop and sell using this concept. So we have been developing this concept technically with them, and we're now throwing the ball to them, and it's up to them to decide.
Thanks. Antero.
Yeah, thanks for this information, and I would like to ask if you did develop already applications for the users of the books.
Well, we saw those three different views. This was a question about did we develop some user interfaces, or what did you want for users applications? What type of
Facility managers or the users of the books could use the application.
Yeah. So the question is if there are any applications further developed for the users, for example, facility managers, and those views what you saw here, those are concepts, so they're not yet working in the field, but we have prototypes of them, so you're able to come today and see them working as application. How does it work, and how you can browse through these different types of views. So we have a tablet view for that, but yeah, it's developing. It's on the development. So
Yeah, there is another question, Jari.
This is more or less a comment. Doesn't make too seriously, but I think the system is useless without information of the available coffee machines and toilets, also and some other reasonable stuff. So you actually need to collaborate with other companies.
yeah, you're right about that.
Any other? Yeah, please.
Just one question, also out of curiosity, is there some ways of interaction or feedback you have got to give the user? Maybe it's related to what we asked, but for example, if someone wants to go there to relax, he or she could see like what are my stress levels at the moment, or something like this.
Yeah, the question is, can the booth give you some feedback of your stress levels or something like that? And not at the moment. So of course we can incorporate something small into them, like a smart ring I'm wearing here right now, that could give my heartbeat and other stuff to the booth, and then it could indicate that on the lights, for example, and turn red when you've been very stressed and you should get out of the booth. Yeah, good idea.
One question related to the business case, but from the cost
Well, at the moment, the work costs quite a lot to put in them because we're doing just prototypes. So when going in large scale, the price would be fairly small, I'd guess. Well, for this type of a booth we developed, we used special type of sensors that I was personally developing at Tampere University of Technology beforehand as a researcher and applying that information in there. So, but there's other simpler techniques that could be used to get some simpler information out of there as well.
Janne was there very, very, very quickly, please.
Yeah, quick question, a follow-up from one in front. So the users can use the apps that you have developed, but do you have any plans to open your whole platform to users so they can also develop the apps that they use?
Well, the question is, are we going to open up the apps for open development, right? Yeah. So no, not at the moment. We don't have any plans for that because we're working with Framery and it's up to them to decide how they want to take this forward. Is it going to be a service or what type of business options does it offer to the end customers? So I can't say anything about that.
Okay, thank you so much. Let's give big applauses to Miika. Okay, and next we have actually two very important persons for Aalto Industrial Internet Campus. They have had really key role in ideating the Industrial Internet Campus at Aalto and then having this crane donation and also like directing the research activities here. So Petri Kuosmanen, professor at Aalto University, and Petri Asikainen, the director of core technology at Konecranes, and they will speak about what is the role of Aalto Industrial Internet Campus collaboration for Konecranes. So please.
Okay, thank you. And by the way, do we look like twins? Because I recognize that we have already the same first name. So. Yeah, it's still early phase of the development, so there might be something to adjust. It will come. I think the years will at least correct the case. I think like after 50 years, I think hopefully we look the same. And hopefully we have synchronized actions. Yeah, that's true. So thank you for this opportunity to come to tell about Konecranes' perspective, why it's so important to be here, what it takes from us to being here, and what are the results that we get and what we expect to get from here. So, few words about the way how we create technology in Konecranes. Of course, we have all this innovation, research, development operations in place, like any huge and big company have and should have. But we cannot make the world ready alone. And there's a lot of things happening outside of the company, this is crystal clear. And that's why we systematically work in cooperation with the universities, research bodies, like Aalto University. And we work also in close partnership with our customers, large industrial partners, and players in that, let's say, industrial field. For example, with customers, we take them really early phase into our new product development projects, and typically we put our pilots out in a real environment in a phase where we still have the project personnel involved in the process running, and it's like really low cost to make these small adjustments in a project and the end product. So that way we can really fit better to the market needs. And this is like daily thing what we do. And of course the last and not least, especially in this digitalization area, is the collaboration with the small and mid-sized companies and the startups. And even though, as I said, that we have muscles to do the innovation, research and development, we still cannot do everything. And with the small startups, which are having like, typically they are quite narrow with their field of their expertise, but they are really, really deep on that. And if you think about moving the business to some other direction where we are now, we cannot keep the speed with the moving this big ship to other directions just by growing the talents in-house by ourselves. So there we need the startups. They already have the knowledge in specific areas. When collaborating with those, we can really move fast. And if they look feasible for our business, so then we start to cooperate. So it gives basically the speed. Okay, let's go then to Aalto Industrial Internet Campus. What this practically means for us, what we invest here, what it takes from us to be here, and why it's so important to be here. So this is also quite natural that Aalto offers this science community with all their networks. And then on the other hand, we as a Konecranes, we are industrial company doing the business. And it is like it's been talking for decades how to make this path from the innovation to the real business faster. And I think this Aalto Industrial Internet Campus really concrete example and platform for that. Well, these kind of things happen. So when we have on the other hand the research and then the business needs, so while we make things happening parallel, that way we can really shorten the line from innovation to the market. And there are actually two kind of research and innovation things that happen that we are looking for. One are those that are really new and that have value for our business. But for some reason, there's some like barrier that it prevents it to be a big business. I think blockchain is a good example. It's like about 30 years old technology, but just recent years it has become like a big, thanks to the low cost of the computing power and the networked world. But if you have this kind of like information, okay, it is good for us, and then there's barriers some other and some cost typically. When it goes down, so we are ready to go fast. And the other thing what we can get here is the visibility for those, let's say, low-hanging fruits, the ideas that can directly land in our business. So then all the, let's say, enablers are ready in the market, and then just like some great innovations come, maybe with research work, and it's already ready to go. So these both two are important for us. And practically how we work here, we have all the crane steering, Ilmatar steering. We practically sit down 4 to 6 times per year with all the stakeholders and with the people that are leading the research programs that are ongoing. We share the information there, and then on both sides, from our business side and from the Aalto University, we also share the latest news, what is ongoing, and a little bit testing, is this, let's say, interesting or not, should we go on this direction, and really like steer the things what are happening here in Industrial Internet Campus. And then the thing what we also do, we have not only like donated the crane here, it's actually part of the facility, and somehow I see it as a platform, so it's not that critical. It's good that it's there, but the important thing is the activity what we do and the research work what we do there. And to keep this alive, we have set it up a couple of things in our own organization. We have named one guy who is this kind of like daily helper with the crane, who comes here if any research have any problem with the crane, or if there's any new data need to be open to the OPC UA or something like that. So we have guy to make a phone call, and half hour he's here and helping the things proceed. So that we try to make the life easy in a research environment, and that is one part. It's like a simple, straightforward, easy, but it likes a lubrication for the wheels. And then if we go this like main topics what we have here, so we have a couple of research projects, and maybe you, Petri, would like to present a bit more about those.
Yes. Yes, and even though Konecranes is involved in most of our research activities, these are always consortium projects. And okay, this DigiTwin project is introduced already today, but there are small and medium-sized companies involved, like Remion and others. Then there are digital twins also. In our case, we have built it around paper machine roll, so in rotor environment, and that project is funded by Academy of Finland, so it's academic research, but also there is a steering group from industry, And this is one demo case, so those who haven't been visiting there yet, you have an opportunity for that after this presentation. And in this Aalto system, we just want to combine traditional physical modeling and machine learning, and which is let's say new technology, but anyway, to put this together and get better understanding how the real physical device operates. Then there is ongoing European Union-funded project about digital calibration certificate. As you know, until now, you get just a print when you make calibration of measuring device, and it's very important that at least in European level and also globally, there could be a standard way to present calibration certificates. And it may sound very simple, but we should globally use SI units, because it creates confusion that there are different kind of units used. And for example, in the States, they haven't been that active in using meters. And but in this kind of certificate, it must be a clear way to introduce the information, and then there must be cybersecurity included. And that's our competence in this project. And in addition, we build a demonstrator around case which is selected to be the rope roll of the overhead crane. So again, we can use this overhead crane as an example. And then what is ongoing and under preparation is that it was a competition of 5 consortiums to be selected for EIT manufacturing, and this is a European project or program to keep manufacturing industry competitive in Europe. And if you write to Google EIT manufacturing, you get more information from there. And for you, just clear numbers. The first part of the program is 7 years, and if everything goes well, it continues another 7 years. For the 7 years, European Union has reserved over 400 million funding, and this is the area. So mainly focused on innovation activities, and I think that this Aalto Industrial Internet Campus is very good example of innovation environment. So this kind of things are supported, and we need Finnish companies and also small and medium-sized companies in this activity. So this is industry-driven activity. And Aalto has taken this topic very seriously, and because we have also this EIT digital and raw materials and so on, we have put everything in one building, and we nominated that building to be EIT House Finland. Actually, I heard a story that it was a hard competition between the capitals that where would be the first EIT house, and in the final stage it was London and Helsinki in the competition, and for some reason London didn't win this European Union project. Okay, then to education, and before introducing more in detail the case for inspection robot, could you, Petri, tell a little bit background story about that?
Yeah, there's actually quite nice story backside of this study was made as part of the mechatronics course. In Konecranes we have this open platform for innovation, so anybody in a company can key in their innovations in our internet, and then others can collaborate and create those ideas. And there was actually one R&D engineer in China who had found out that this fast trains in China are using monitoring system where camera is looking the trains while they're passing by. So there's somewhere probably under the train cameras, and they evaluate the condition of some wheels and some other wearing parts there. And then he started to think, could this technology be somehow utilizable to our business? While the trains are pretty fast, so the camera technology and all the analytics need to be pretty good actually. And then the idea came to Konecranes, and then our innovation manager in our innovations team thought that okay, the AIIC could be the good place to do this, and actually this mechatronics course could be nice place to little bit look at how this idea would look in a crane environment. So in a way we were like adapting ideas from China and bringing it here. Maybe also some wake-up call for the Europe to put the innovation in the Europe.
So is it so that we show to China how to be a quick copier? So, okay, but it was our student who made, or it was 3 students, and one of them is giving a demonstration, and actually now he's recruited to Konecranes. And the idea is that there is a low-cost camera taking pictures or video clips, and you can see that now it's checking the condition of rope, and then it goes further to the next components, and finally it will check so that itself that it's that the camera system and the robot is okay, and you can think that if you have, for example, in Singapore, you should check the quality or condition of a rope. So to send a maintenance person to do the check, or you can do it remotely, and you can get the documentation clearly. So I think that this gives quite a lot of benefit in practice, and the components in the study project it cost 600 euros or something. So it's doable. Okay, and if we jump to doctoral thesis and master thesis, so this is an example of master thesis actually done by, okay, this is Juuso, but there will be a video clip if you can start it. It's done by a student from computer science, so we cooperate also at Aalto over borderlines of different disciplines, and this is belongs to this funny amateur videos I have done it by myself, and we had visitors from industry, and this lady is from Siemens, Elisa Rönkä, and she had never used any industrial device like overhead crane, and she is controlling with AR glasses, Microsoft HoloLens devices, and just clicking fingers, and you can hear relays clicking after the signal given by fingers.
So it's not only easy, also fun, as you can see from her smiling face.
Okay, but this kind of thesis works are done, and so just to show what's possible, and maybe in the future this could be a real application. Then for more industrial purposes was done a case where we make a precision positioning with the crane. As you know, you have the ropes, so it's very flexible adjustment of the workpiece, and even though otherwise the overhead crane it's like 3-axis robot. And in this case, we have improved the accuracy by adding sensors which measure locally the position of the workpiece, and also take the control over the control system of the crane. And it's again used low-cost components like Raspberry Pi and low-cost sensors, and we could clearly improve the accuracy of the system. And actually this simulates the Azipod stator which is installed to the frame. So the real component is about 100 tons. And that's project is done with Juuso and Heikki Sjöman, who is actually doing his doctoral thesis in Norwegian University of Technology, and it's under inspection now. And maybe you could tell a little bit about the future perspectives.
Yeah, a couple of words about the coming future. So this has been so fruitful and good environment that for sure we will be continuing here. And there are discussions ongoing with some Finnish and some European level research programs that hopefully are landing here. And we are pretty much working in industrial internet and digitalization also in our company, also on the other fields like on the sales and all the functions what we have in a company. But Aalto Industrial Internet Campus will have a big role on those. And then I think one breaking news to the end of the presentation is that actually this week we decided in Konecranes that we will open this development environment in the Ilmatar crane for all the like third parties, startups, small companies to join us. So this will happen gradually and state by state, so following the, let's say, industrial environment laws and the practices what comes to trust and data security and cyber security. And also I think questions related to those are that we want to study at the same time we open the platform. So that's in short, and well, I would like to just say that if you are interested about this environment, so I can recommend from my side that it's been really good and fruitful, and we are happy to work together with also new incomers.
And if you're interested to join our team, you can contact either Suvi or Jari Juhanko, who is responsible for this environment.
I'm not Jari that was here before. Please contact me if you want to join us.
And this is also a good way to join these European research communities. And so thank you.
Thank you.
Okay, thank you. May I say twin Petris or?
Yeah, just to say words.
Yes, that's good. So there is some time for questions, but maybe actually I'll start about this opening. So could you a little bit more elaborate what it means? So will you bring up the problems or potential use cases as well as the platform?
Yeah, of course the questions and problems are there, but also think about the engineering data and the live data that the crane is creating. And there are quite a lot of topics related, for example, to IT, simply how to technically connect and what are the methods to identify the users and control the user access and that kind of stuff, what is like done typically now in a closed environments in the industry. So basic connection technology is there, but the practices for this kind of open environment is like pretty much to be developed. So those are one of the key parts.
Thank you. Any questions from audience?
Actually, I could make some questions for you if you are not active. So what do you think? Is it more challenging to solve the technical problems in data sharing or legal issues? Any? Okay, I agree, because we had one project of data sharing, and finally we recognized that technical things are easier to solve than legal issues, and it requires a lot preparation, what kind of data and classification and so on. And I think it will be one good topic to do in this environment as well.
Yeah, and it's important to collect those questions, and also like we are very well aware and prepared for those questions also. We have professionals in-house to handle those, because that are key parts of the successful business also.
Mm-hmm.
Hello, I would like to ask if this data that you found in this process, is it available for everyone, open data, or there's some?
At the moment, not, but as said, it was like gradually it will be opened. And typically it's like that if we have any, like, let's say research or any studies ongoing, so related to projects, we are going through those questions that need to be asked there, and then looking at how we create the environment. But the technology pretty much is already there. So we have, well, for example, OPC UA, which is strongly going to that direction, that it will be some level of industry standard for this kind of machine-to-machine communication. So it's like a good starting point. And also we have activists actually in Central Europe what comes to Industry 4.0, and we get also like some messages and feedback from there, so we can actually adjust the things what we do, looking on a wider perspective.
And we are open for proposals for pilot cases.
Yeah, thank you. I think the data availability and access, it's a big issue, and also during the demos I participated a couple of discussions how to share, and it's also promoted pretty much on research side nowadays that you put your data available, you also publish, but you publish your data. Any other question? Okay, if not any, I give my deepest thanks. It was really good, and I think these cases really opened the opportunities what you might have around the crane or around the industrial internet campus. So even though you have to do something new, but and it can be a little bit vague in the beginning, but then it seems to be happening. So thank you.
Thanks.
Okay, we'll go forward in our program, and I asked Tatu Koljonen to kind of like summarize the day and show the key findings, and Tatu is executive in residence at Aalto University, and he has background from EIT labs and lots of like different like networked projects and ecosystems. I thought that he would be good to summarize the day. So please, Tatu, whenever you are ready.
Is the mic on? Yes. So thank you for the opportunity and invitation to summarize. I think the biggest learning for me today was Valtteri Peltoran's that you look great. It's a great learning. So, but we started off with Juha Takkunen's digital disruption motivation speak. So it will hit everybody and nobody. There's no way back in time. Then we went to Kari Tammi's replacing engineering witchcraft with digital twins, and already in this first presentation there was this question of what is the definition of a digital twin, how it differs from IoT, because IoT is also having connectivity, having identity, having some inference there, and so one definition was this Juuso Autiosalo's definition that it's the cyber part, so it's all the things that are done with when you have these data and identities available. But clearly, whether digital twins are really twins, or are they replicas, digital replicas of things, or are they just digital of things which are like IoT interpretation of these things remains a topic for the day. Clearly, what everybody agrees that digital twins are used to understanding, predicting, and optimizing systems over the whole product lifetime, maybe. And second topic that Kari raised is the scaling. How do we scale these digital twins? If we have a digital twin of every possible cars, and will we have 100 million digital twins? I would, in my mind, see this as an opportunity, because digital are digital, and the margin cost of digital is zero or close to zero, and while with physical things it is quite much more. So this is maybe one challenge that, for me at least, from today, how to utilize this hyperscaling properties of the digital twin models. Of course, if you include in the digital twin the user behavior that has accumulated during the use of the product, then they are not that much reusable or scalable. But so I would challenge that we should look at that direction. That can we make artificial intelligence playing in the same way as Google did with Go and chess? That there are artificial adversary games that find the optimal strategy of some industrial process, for example. Then, okay, Konecranes, Valtteri showed how this component information can be used to detect the weak points of components, but clearly what we are still missing are these price tags that we can put on utilizing these digital twins. How much more can we charge, and how much value it's in the end for the end customers? At least it wasn't visible for the audience. Ville Pantsar showed the traceability challenges and how this whole product life cycle management can be included in these digital twin tools. And Juuso went to the demo part and the ecosystem building question. So there, what I picked up, though, what was most curious in my ears was this that do we, and which might be another direction for this digital twin research, that for example for this project is the methods for accurate models. How do we generate accurate models, and how do we determine or identify the accuracy needed? Because in some cases, as we saw in this rotator, the paper mill demo, it is enough just to know what frequency resonates and avoid those frequencies, and that the model doesn't have to be the partial differential equation of the roll, but it requires that you have the chart of the resonance frequencies and or something like that. So identification of the model granularity or accuracy, and updating, or and could there be even some kind of a marketplace for these models or various digital twin components? Are the components reusable and to what extent, and can they be sold and bought? And this marketplace could be one area that where this ecosystem building could come into question as well. Again, this utilizing the scaling, do we have can we see some emergent phenomena in this? Do we have, to my understanding, we don't have a well-established programming environment for digital twins or the platform. Is that something that we could start to work for, try to build programming environment for digital twins? What parts are missing? Of course, there are GEs and Microsofts and those that are or IBM's providing their parts, but not all. Clearly, if we look at the ecosystem part, we have an ecosystem here. Aalto Industrial Internet Campus is a great one that we should utilize. Typically, ecosystems otherwise they are always spanned with the technology platform. Platform span, or some kind of platform spans an ecosystem, and it's in my vocabulary, ecosystem is a word that doesn't exist without a platform, some kind of platform that enables open innovations or innovation without predetermined or beforehand contracts. So that's open innovation. If you have beforehand contracts, then you are outsourcing and subcontracting, but in an ecosystem you don't have beforehand contracts, and that requires technology platforms, economic platforms, and interest in the subject. And so if we want to build a bigger ecosystem here, we should consider is there some kind of platform that we could build in order to accommodate that. Whether it's Aalto Industrial Internet Campus, it doesn't sound a platform, it's more like a place. We have Smart Otaniemi innovation ecosystem here, also building up on smart energy area. Those could be used. Clearly these EIT, knowledge and innovation communities, are such that could be used in building those kind of technology platforms, at least for funding and attention gathering instruments. So I would, and of course we have also in Business Finland days having activities like Reboot IoT Factory and that kind of instruments, so which could be used. But as Petri Asikainen said it, the normal mode of operation is that companies do their business, universities do the research, provide the good people to them, and then we have the technology and software providers, and then the SMEs and the startup communities, and those should in normal case play together in a living ecosystem. Okay, to finish, I would say that I learned a lot today, and you have a good ecosystem already with this Aalto Industrial Internet Campus, but let's use these other kicks and other instruments as well. And if you are disagreeing with my interpretations, please comment and ask.
Thank you, Tatu. Anything you want to add or comment or disagree as he wishes, but I got scalability and then this platform thoughts in my head, like
and the model.
A model.
The accurate models.
That's a very good summary.
Thank you.
Thank you. Let's give a hand to Tatu. Okay. Yeah. This is really good summary and very good to have also like listeners from little bit, let's say, from the borders of this industrial internet campus. Yes, so there are a couple of practical things, but in order to avoid thanking correct people, let's start with thanks. So I cannot list all the names who have contributed, but I was thinking that I would list 3 names, and Juuso Autiosalo has been running the project, and he's pretty much behind the program today and demos and arranging that everything works. And then Suvi Lavinto has done the communication part and also watching that everything works and reminding us to do something when needed. And then Seija Erander-Luukkainen, who is probably not here, has been also participating in the organization. And then whole the machine design group, laboratory staff have really like done a lot. Like I was myself impressed, like how even the snow is painted for our event and and it seemed that everything worked in demos. So let's give a big hand to all. Then thanks for the audience for clever questions and presenters for good presentations as well. So now actually the lecture part is gone and there is still coffee and demonstrations in the same place we had lunch, and they continue for 1 hour, and I think only one group went to this A-rotor demo Professor Kuosmanen showed in his presentation. So now there is another opportunity at 3 p.m. sharp to go that, and I believe the idea was the same, that you will be picked up from Industrial Internet Campus for the demo. So yes, once more, thanks for participation and questions and presentations, and then outside the official program there is unofficial after work in Fat Lizard restaurant, and now be careful when you are leaving this building. In order to get coffee you have to go left, and in order to get Fat Lizard you have to go right, so first left and then back. Okay, thank you.